In this video, I want to focus on x and y intercepts, specifically regarding linear equations. But everything we're going to talk about in this section actually applies to all equations. If we want to find their intercepts, you can use the same strategies. It's just with more complex types of equations, it might be a little bit harder. But we'll circle back to these same basics later. And in the last video, we talked about, well, the y-intercept always occurs when x equals 0. And actually, notice that there's a typo in the slides, which I just now noticed was there. Who knows how long this has been here. I probably fix it every semester. But if you want to find the y-intercept, you always want to set x equal to 0, and define the x-intercept, you want to set y equal to 0. And I kind of mentioned why that's the case in the last video, but if x is 0, you're going to solve whatever value of y happens with the equation. But when x is 0, that's always going to be on the y-axis, because the y-axis, well, it's y, and you would typically think, well, shouldn't that be when y is equal to 0? No, it's because the y-axis is always oriented when x is 0, because that is where it crosses the x-axis. And exactly the same for if we wanted to know, well, where is the x-intercept, which is something that we're going to solve in this video, that always occurs not when x is 0, but when y is 0, because, right, that's the intersection of the x-axis with the y-axis. And that's exactly what I wanted to focus on, is how do we solve the x-intercept? But it's exactly the same way, but we just plug in 0 in a different spot. Because here we figured out where is the y-intercept by plugging in x is equal to 0. So, as you would probably guess, if we want to find the x-intercept, we want to know, well, what happens when y is equal to 0? So extending our table a little bit, and really what I could do is just plug in 0 on the other side, and then go back and try to figure out what x is. And sometimes this might be a little bit harder, because if I were to plug into the equation, well, I'm not plugging into here because I'm plugging into here, because I already know what happens when x is 0. Now I want to know, well, what happens if y were equal to 0. So I'd have 0 is equal to 3x minus 4. And now we've canceled out one of our variables, and we're left with a linear equation with just one variable. And now we solve using a lot of the techniques we talked about in chapter 1. Well, we could add 4 to both sides and divide by 3, which would leave us that x is equal to 4/3, and that would be our x-intercept. And if we're looking at the graph, it should appear to be the same. And notice that it was somewhere between 1 and 2, at least it appeared on my little rough graph that I made right here. And you could write it as a decimal, 1.33333 repeating, or approximate it approximately 1.3 or 1.33. Or again, with my math lab, just if it's asking for those things, just pay attention to if it wants it as a fraction or as a decimal or whatever else. But it should, it should look correct. It should pass what I often call the smell test. Does it smell good, or does it smell funny? And based on what I see, that smells good. And anyways, that pretty much wraps up this example. Let's do another example, because this is sort of an alternative technique for graphing linear equations, which is, again, depending on who you had algebra with, there's a lot of different ways to approach the problem to begin with. Like here, I sort of just picked random numbers and graphed them, but another way to start the graph of a line is by just using, by just graphing the intercepts. Because as I said, really, it only takes 2 points to find out what a graph looks like. And why not figure out the intercepts to begin with? And so if you want to solve the intercepts, what you could always start with is a t-table where you put 0 for both x and y and solve the zeros first. And again, each one of those will give me a different intercept. And if I find the two intercepts, I can just connect the two intercepts together. There we go. But usually I recommend finding more than 2 points, because, I don't know about you, but a lot of times it's really easy to make a mistake with basic arithmetic, right? We just plug in a number, we accidentally mess up the numbers somehow and get the wrong answer. And now, again, that's not really a big deal, because mistakes happen to everyone. But what is something that's better to do is, instead of just graphing 2 points, it's often better to graph 3 or 4 or 5 points. That way I can tell that I got them all right, because they should appear in a straight line. If you have a point that's not in that line, that tells you, okay, something went wrong, what was it? And you should probably go back and check the math you did for that specific point. But anyways, let's start off by plugging in x is equal to 0 in the equation. So if I start off with the first point, I would have, well, 2 times 0 minus y is equal to 3. And of course, anything times 0 is 0. Whoops, sorry, you can't see that. There we go. And so I'm starting off by solving the first point, and that would just give me negative y is equal to 3, which I could negate both sides of the equation, and that would leave me with y is equal to negative 3. So that gives me, again, the y-intercept, which is when x is 0. And now, let's say I wanted to solve the... and again, this is really easy to mix up. The x-intercept is when y is equal to 0, vice versa. And it's more obvious once you actually graph the points, you can kind of tell that. But if I were to plug in y is equal to 0, well, that would be 2x minus 0 is equal to 3. And of course, minus 0 is 0. So that would just be 2x equal 3. And dividing by 2, I would get 3/2, or 1.5 if you prefer decimals. Sorry, again, I need to be careful about where my screen is set from my tablet. But that would give me 1.5 as my y-intercept. And then basically, once I've solved this little mini t-table with the 2 zeros there, I'm ready to go for graphing it. And I can also tell the slope by checking what's the difference between them. But in the next video, I want to focus more on slope and using various formulas to quantify. But oops, I want to make a normal graph, not a t-table. So now, well, I have 0, negative 3, which is going to be my y-intercept, and 1.5, 0, which is going to be my x-intercept. And you might be wondering, should I be labeling my graphs? Should I be graphing tick marks and so forth? In general, yes, but sometimes, I don't want these videos to take forever. So you'll notice that sometimes I'm not very careful with my graphs. You generally should be more careful than I am. But, a lot of times on an exam, I'd provide you with graph paper or with a graph on the exam so that you don't have to create these from scratch. But if you're working on homework and you're not printing something out or working on a pre-think packet, you should do your best to make the graph as neat as possible, though you don't necessarily need to spend forever making it look pretty, depending on what you want to do. For me, I'm trying to keep the videos short, so anyways, I would have my graph of my line, so forth. Anyways, in the next video, we'll focus more on slope. So just to sort of recap here, I'd refer to this as the intercept method of graphing. Basically, find the intercepts and graph, whereas the other method is just the regular t-table, guess and check, kind of randomly guess some numbers, graph all the points. But at the end of the day, you can graph these however you want. And there are actually more ways to graph too, which we'll talk about. Like technically, you can graph a line like this without doing any math, just by reading it. That's the value of slope-intercept form. If it's in slope-intercept form, I already know the slope and I know the intercept, so I could just start with the y-intercept, find the next point by using the slope, and so on. Every other point will be 3, 1, rise, run from there on out. So I could really find all the points without having to do any math. But when we're in standard form or another form, it's not necessarily so obvious, though technically you can always convert from standard to slope-intercept. Anyways, I'll wrap this one up. Next one, we'll talk more about slope.